Hello everybody. So this particular process you're going to learn today is kind of the other side of the coin of combination. We talked about combination last time that we had a lesson, and basically I said that was a type of elimination, but I'm going to teach them separately to make it easier for you. And this is kind of why, because elimination as a whole can also entail having to do an extra step, which is finding the greatest common factor and using equivalents. It's pretty similar to something you'd see when you're trying to, let's say, add fractions or subtract fractions that don't have the same denominator. But we'll go over what that exactly means today. This is also the second to last type of method that you could use to solve systems of equations in two variables. So let's go ahead and take a look at what we have here today. Now, when you're going to be solving systems of equations using elimination, you would use this method when the coefficients that are given in front of the variables, none of them would have the same coefficient basically between the like variables. So the x's don't have the same coefficients and the y's don't have the same coefficients to each other. The method that you would take to solve this when using elimination would be to find the greatest common factor between coefficients of one of the variables first. So pick your x or pick your y's and try to get the numbers in front to match. You would multiply everything in each equation, not just the variable you pick, but everything in the equation by the same number that you'd be using to create the greatest common factor. And once you've gotten that and changed each of the equations, you would then be using combination once those coefficients match to solve for the first variable. And once you found the first variable, don't forget to find also the second variable. So let's take a look at three different types of equations that you may encounter when you're going to be using this method. So the first type is where you take a look at the variables, and let's look at the variables in this equation right here. You have a 2x, a 5y, then you got a 4x, and a negative 3y in the second equation. Now, this circumstance that you're looking at here would be when you notice that the smaller of one of the coefficients of one of the variables is already a factor of the coefficient of the same variable in the second equation. Now, when you encounter something like that, what you're basically going to do is you only have to change one of the two equations, the one with the smaller coefficient. In this case, when I look at these particular variables and their coefficients, the 2 and the 2x in the first equation can go into the 4 and the 4x in the second equation. So that makes it an easy change for me because I only have to change this equation to an equivalent. The other one can stay. So what would happen is I would then tell myself, all right, well, what do I multiply the 2 by to make it 4? And the answer to that is 2. So I would take this whole thing here and multiply it by 2. And what that does is I distribute the 2 to all three terms there, and it creates a new equation for me. 4x plus 10y equals 24 times 2 is 48. Okay. Now, in doing this, what I am essentially doing is making an equivalent in the first equation. Now, if 2x plus 5y is 24, if I doubled everything in that, it is the same answer either way. So that's why this method works. And since I changed the first one, I do not have to change the second one only because now the x terms match. So the second one says 4x minus 3y equals, and I believe that says 2. Yep, 2. Okay. Now, when I look at this equation next, I can then use combination to solve the equation. So I can combine the two. Now, if we recall from last lesson, once you've matched the coefficients up, you see if they're the same sign or opposite sign. In this case, since they're the same sign, you're going to need to subtract the second equation from the first. So to subtract this, I have to change all the signs. This becomes a minus, that becomes a plus, and that becomes a minus. Okay. And then from here, you basically go ahead and solve. Now, with this particular equation, let's see here. I would have 4x minus 4x cancels. I would end up with 10y plus 3y makes 13y. And then I would get 48 minus 2 is 46. Now this isn't going to create a whole number. Tell you what, I'm going to change this to a 5. There we go. Just for the sake of making this whole numbers here. Completely thought of this equation off the top of my head, right off the start here. Okay, that will be better, and that will equal 3 this way. And we'll change that to a 5. Okay, and then when we do that, we'll get 45 over 15 equals 3. So we'll get y equals 3. And this last step says just don't forget to also find the second variable. In this particular case, you can pick either one of the equations and then plug the value you just solved for into that equation to find the second number. So let's go, and I guess in the beginning of this equation, since I changed the numbers around, you probably could have just used combination to start with, but this is just how elimination works here. Let's just go ahead and do this here. 24, and then I would get 2x plus 15 equals 24. 2x equals 9. And then x would equal 9 over 2, or 4.5. So then at the very end here, I would get my answer as 4.5 and 3. And if you were to plug those both into the original equations that we had there, they would equal out. So that's one way that you would use elimination, is when there's one number that can go into the other number for a variable, and you just change one equation. The second way you might do this would be when you notice that none of them are factors, like in this second example here. So to do that, you would just pick either the x or the y and decide which one you want to change. So for me, I look at the 2 and the 5, the 7 and the 3. I think it would be easier to do the 2 and the 5 personally and do the x's. It wouldn't really matter which one you get rid of here though. That is a big fat arrow. Let's make sure our drawing arrow is smaller. That did not need to be like that. There we go. So when I look at the 2 and the 5, and the reason I'm going to pick the 2 and the 5, I guess it would have worked in either way in this part of the equation, but I saw there was a minus and a plus as well. Sometimes it's easier to do that so you don't have to worry about changing signs. So the 2 and the 5, the smallest number that both 2 and 5 can go into, that they're both factors of, is 10. 5 times 2 is 10. So this is going to be something where I times by 2, because 5 times 2 is 10. And on the bottom equation, in order to make 10, I'd be multiplying by 5. So you notice you're both going to change these two to the same thing. But when I do this, you have to do both whole equations by that number. So it's 2 times 5, x makes 10x, minus 7 times 2x is 14y there. And then, I notice I said x there, but it should be y. Then 2 times 19 would be 38. Okay. Now underneath this, I would have negative 2 times 5. X is negative 10x plus 3y times 5 is 15y, and then I would get equals 5 times 5 is 25. Okay, now that we got that, we can use our combination. So now that we got that, we would go here. Let's combine them. The 10x's cancel. Negative 14 and then a 15y actually just makes y. 1y is left. That would equal, if we add them together, 38 plus 25. That's a big old number. That's a 63 for you. So y is 63 in that circumstance. And then you'd have to go back and figure out what x would be. You can really use either one here. I'm going to go with, why not the negative 2x plus 3y. So negative 2x plus 3y equals 5. Okay, and then we've got negative 2x plus 3 times 63 equals 5. Negative 2x plus 3 times 63 makes 189 equals 5. Negative 2x equals negative 184. And then x would equal, in this case, 92. All right, so my solutions would be 92 and 63. And if we looked at the other one, if you put that into your calculator, if you'd like, just to double check your answer, 92 times 5 minus 7 times 63 does make 19. So, last one here, another circumstance, one final circumstance you may see would be in this particular case where you may notice that you could have possibly used substitution, but you didn't really want to use substitution. Now, for some of you who don't feel as confident in substitution as a method, you could also use elimination if you want to. So to use elimination for this, what you would do is look at the one that has a coefficient of 1, in this case this x. All right? Now, what you can do with that is just multiply it by the coefficient in the second equation. So there's a 5, so I'm going to times everything here by 5. All right? So then 5 times x makes 5x plus 6 times 5y is 30y. And 25 times 5 is 125. Okay, and then beneath this, we just keep the same equation. And then what we would do here is we would get into the combination mode. So let me just draw my dividing line like we usually do here. And then we would go ahead and start combining here. So these are both the same number and same sign, so you got to subtract. That's going to be a minus. This is going to be a minus, and that's going to be a minus. Okay, so then when we do the combination, we would have the 5x's cancel. 30 minus 12 would make 18y equals 125 minus 5 is 120. And then when we divide by 18, y would equal, in that case, 120 divided by 18. I don't think that's actually a whole number, but gives you 6 2/3. Alright, so 6 2/3 is what we have there. Another way of writing that would be 6.6 repeating, or 6.7. Or you can even write that as, I guess that kind of goes off your screen there, but another way to write that would be 20/3. A lot of different ways to write it, but I would prefer the 20/3 personally, because what you're going to do is try to use the first equation here, x plus 6y equals 25, to get the x term. And when we do that, because 3 can go into the 6, you can actually cancel out the denominator there. So we would have that. Okay. And then if we were to simplify that, that would be 2 times 20, which is 40. And then x would equal, in this case, negative 15. All right, now if we were to double check our answers, negative 15 times 5 plus 6.7 times 12, it does equal 5. So your answer here would be minus 15, comma, 6.7. All right, so those are the 3 different circumstances you might use elimination. When you have one variable that has a coefficient that's a factor of another, when there is a situation where there are no common factors amongst the coefficients, or when you notice that the coefficient of one of the equations has a 1, which is just the variable by itself, and you don't feel like using substitution. So we'll cover this more in class, but this is just a good sort of notes video for you.